Hi dear student, now we are discussing 2025 JEE Mains 22nd January second shift question paper. It is memory based question paper. It is not exactly question paper. It may be have some variations questions. It is guess pay, means we can say which is the students after writing, which is they remembered, that's typed, and we are discussing here. See here. First question they given, this is toluene and CrO2Cl2 in presence of CS2Cl2. It is solvent anyway. And A we are expecting, then followed by hydrolysis we are getting B. After treating with NaHCO3, again product we are getting. So the products they are expecting, the product is. So this is directly from NCERT question. This is called Itard reaction. We can expect. See where they given this reaction directly from NCERT. So you can find here toluene, then CrO2Cl2, CS2 also non-polar solvent, or CS2Cl2 also you can use. Then chromium complex I am getting here. Then followed by hydrolysis will get benzaldehyde. Got it? And again they given here one more NaHSO3 also. That's they given here, you can find out. This is the reaction. What is the use of this one NaHSO3 reaction? We make and see here before point C. It is used for the separation and purification of aldehydes and ketones. What is the NaHSO3 role here? Separation and purification of the aldehydes ketones. You can find reaction B under the last line. So what you can expect the answer here? So we can expect here answer is 2. Okay. If you do hydrolysis, again you will get aldehyde only back. Again you can get aldehyde only back. So option 2 is the correct one. Next. Density of 3M NaOH is 1.25 gram per ml. Molality of solution. So molality, we have direct formula also. Molality equal to, this is molality, small m. Molality equal to 1000 into molarity by 1000 into density minus molarity into m naught. M naught nothing but solvent of molecular weight of solute. I can write here solute. By substituting all the values 3 into 1000 by, so 1000 into density how much? 1.25 minus again molarity 3, molecular weight of NaOH is 40. By solving this you can get approximately 2.65. So this is your answer. Actually this is the one method. Other method also you can try. So 3m nothing but molarity equal to 3m nothing but n by v. This is 3 moles per how many liters? 1 liter. So n equal to 3 moles. V equal to 1000 ml. Then by applying here density equal to mass by volume, then mass equal to density is how much? 1.25 and volume is 1000. I can get here 1250. This is the grams of solution. It is solution only in the density. Once you got solution weight, I can get solvent mass. Solvent mass equal to solution mass minus solute. Solute how much here? 3 into NaOH mass 40. By subtracting, we can get the here solvent mass. Once we got solvent mass, you can apply the molality formula. What is the molality here? We are getting N by W grams of solvent into 1000. This is the formula. N equal to 3 moles. Weight of solvent I can get here 1250 minus 3 into 40 into 1000. By solving also we can get molality answers. Okay, right. And third question, arrange the according to CFSE value. Which is the highest CFSE? First check the complexes, which is octahedral and tetrahedral. Octahedral complex have more CFSE than tetrahedral. This is the basic idea. After that, and ligand you have to see, which is a strong field ligand. And chelating ligands, it have much more CFSE than weak field ligands. So in this case, chelating ligand or ring formation, that is the EN, ethylene diamine. It is bidentate ligand and it can form ring. That is the reason it is much more splitting and more CFSE value. So fourth is the we are expecting highest. Fourth is we are expecting highest. Got it? After that, so in these two options you have to choose. Then 2 and 3 you can decide. 2 is cobalt plus 3 charge and 3 is cobalt plus 2. Which is more charge, it have more CFSE value. Okay, which is more charge, it have more attractions and more splitting and more CFSE value. Next one is 2. So this the option is matching, you can find. And 1 is least, reason it is tetrahedral complex. I hope you can get the answer. Next, stability order of the cations. When we are seeing stability order of the cations, first resonance effect is more priority, then hyperconjugation, then inductive effect. And positive charge stabilized by plus I or plus M group and hyperconjugation. These are they have to keep in mind. Anyway, these are positive. It is plus M group. And here also plus M is there. But OME can access minus I group also. It can access minus I also because more electronegative. It is also minus I. When plus M is common, minus I deciding. At C, ortho position, minus I character, minus R plus I. Its character is ortho is greater meta and para. So little bit here withdrawing character is there at C, option C. So that is the reason A is more stable. Here A is more stable means which options is matching you have to see. So A is there in 1 and 3 options. Next you have to see C only next because plus M group and AC. So this is the first thing. By looking 2 options we can answer A, C. It is more plus M, that's a more stable. Got it? In the case of B and D you can choose. Again, why D is here plus I character is there as well as hyperconjugation. Hyperconjugation is equal at ortho and para. So it is not the deciding factor, only plus I factor is deciding. At ortho position more the plus I, that's why more stable. Next, which of the following anion will not undergo disproportionation? So disproportionation, all intermediate oxidation states may can show disproportionation. So here how much oxidation state you can find? Plus 3, here plus 5, here plus 1, it is plus 7. So chlorine is the maximum oxidation number plus 7. It can't lose more electrons. Only chance it can gain electrons. It can get either minus 1, 0, plus 1 like that. But it can't get Cl plus 8 or like this. Not possible. So it can't lose electrons. Only gaining. Gaining means it can act as always oxidizing agent. So answer 1 we can expect. But remaining you can get. Suppose ClO3 minus, it is plus 5. It may can reach up to plus 7. Oxidation is possible. It may can go plus 3 or you can write plus 1, 0, minus 1. So 2 chances possible for this one. Got it? It can go disproportionation. Similarly remaining also. So 1 is not possible for disproportionation. Actually it is dipole moment compared to dipole moment. A little bit we are expecting factor based questions because not easy to remember easily. But that's up to you. So it is experimental value we are expecting here. HBr we are getting here approximately 0.79 and CHCl3 1.04 and one more H2S we have here 0.95 and it is approximately we are expecting 0.230. So you can see the values, then you can say answer. Which is the highest here? 2 is highest. Next highest 3. So Which one you are expecting answer here? Option 3. Given below are two statements. Say which is going to be correct we can expect here. Lassine test is used for detecting of nitrogen, phosphorus, sulfur and halogen. It is direct statement from NCERT book. So it is correct only. Lassine's extraction is made with magnesium. Magnesium is wrong. Instead of magnesium, sodium they given, it is correct. So statement 2 is wrong, statement 1 is correct. And which one has two secondary hydrogen atoms? It is very fundamental question. If you know the structure, how to write, if you know how to write structure, then you can answer this question. So we can see the structures here randomly. So I am choosing here, suppose structure 1 you have to write. So total heptane. Heptane means you have to write 7 carbons like this. Okay, 7. And 2 methyl, next 4 methyl. So it is secondary carbon, it is also secondary. We have how many hydrogens here? These are secondary. Got it? Next tetramethyl heptane, 2 secondary hydrogens. So here 2 hydrogens we have, here also 2, here also 2. It is even 4. Here also one more. So 2. Total 6 secondary hydrogens is possible for us. So which is the secondary carbons? This is secondary, this is secondary, this is. So it is not the answer. So we can write the fourth one. So pentane. So 5 carbons we can choose first. Then second carbon you can see any side you can choose secondary, and this is ethyl. Now we can check it. How many secondary carbons here? They are asking 2 secondary hydrogen atoms. Which one has 2 secondary hydrogen atoms? So 3 ethyl, 2 comma 2 dimethyl pentane. So this pentane only, it is the secondary carbon. I have 2 hydrogens here. And what about here? It is also secondary carbon. Okay, ethyl only, na they given. See 3 ethyl, third position ethyl. This is 3 ethyl pentane. It is also have 2, right? And here 3, not possible. So secondary hydrogen carbon atoms is, I think so, correct this question we are expecting. So in the case of this one, secondary hydrogen contain carbon, 2 carbon atoms means in this is the answer. So it may be little bit print mistake. Secondary butyl cyclohexane when react with Br2 in presence of sunlight, it is free radical substitution reaction. Now we can see free radical substitution reaction. Secondary butyl cyclohexane. Cyclohexane is the structure. Secondary butyl mean at secondary carbon. Okay, at secondary carbon they attaches. So we are writing this structure. So find the secondary carbon. Sorry, secondary butyl. It is butyl. Butyl means how many carbons? 4. See, this is secondary butyl at secondary carbon. So when we are doing bromination in presence of H nu, so rate of reaction is tertiary hydrogen is more reactive, secondary hydrogen and primary hydrogen. So you can identify the here first structure we can identify. So here structures we are expecting, correct one is possible, and fourth one also correct structure, and we can see second also correct structure. So third option I am eliminating because structure itself not correct. Got it? So now we can see the alpha hydrogen shortage. Suppose here I am substituting. Here suppose I am getting bromine. Assume that one option 1. In this position I am getting free radical means stabilized by here 3 alpha hydrogens, here 2 alpha hydrogens, here 1 alpha. I have 4 alpha hydrogens total. Sorry, 2, 3, 1. Total 6 alpha hydrogens. So 6 hyperconjugative structures is possible. and remaining is not at all tertiary carbon, they didn't substitute, so we are expecting directly answer is 1, because tertiary hydrogen is more reactive for radical substitution reaction. Thank you.